Hello and welcome everyone. Today I'm dropping this video to show you how to derive the final equation of the Compton effect. So from the quantum theory we know that photon has a particle-like behavior except for the absence of gross mass. So we can treat the collision between an electron and a photon in the same manner we treat the collision between two billboard ball in classical mechanics. So this is our incident photon that strikes stationary electron. Then the electron is deflected at an angle theta, and the photon is deflected at an angle phi. Now, from the well-known equation of total energy, we get that the photon has zero rate mass. Thereby, we get the momentum of photon is h nu by c versus the velocity of light. Now, if the wavelengths of the photons are nu and nu prime respectively before and after the collision, then the energy gained by the electron will be the energy before and after the collision of the photon, that is h nu minus h nu prime. Now we are taking momentum along two radial axes, namely the x and y axis. So along x axis the initial momentum is the momentum of photon and plus the momentum of the initial momentum of electron, as because initially the electron was at rest, so the initial momentum of electron will be 0, where the initial momentum of the photon will be h nu by c. Then taking component along the x-axis, we get that the final momentum along x-axis of the photon will be h nu prime by c cos phi, and the final momentum of the electron along x-axis will be p cos theta. From that we get that equation pc cos theta equals h nu minus h nu prime cos phi. This is our equation number 1. Now along y-axis we are taking the vertical components. So initially along x-axis both the photon and the electron were at rest, so the initial momentum along the y-axis for both the photon and electron were 0. And we see if we take a vertical component of photon along the y-axis, it directs in the positive y-axis, where if we take the vertical component of electron along y-axis, it points at the negative y-axis. That's why here we put a minus before p sine theta. From that we get this equation. Now squaring both the equation and adding them together, we get p square c square equal to this. Now it's time for analyze the energy of the electron, where we know the total energy is the combination of kinetic and potential energy, that is T plus f naught c square, and from special theory of relativity we get that total energy E will be equals root over m naught c square c to the power 4 plus p square c square. From that we get another formula of p square c square using T equals h nu minus h nu prime. So from simple algebraic simplification we get this line. That's pretty straightforward calculation. Now using the velocity of light equals the frequency, and frequency multiplied by the wavelength, that is mu will be equals c by lambda, we get the final equation of the Compton effect, that is the change in wavelength of the scattered and non-scattered photons is equal to this, where this quantity is known to be the Compton wavelength. The whole quantity h by m naught c is known as the Compton wavelength. Thank you.